have a seemingly impossible task before me, and that is to finish recording this video before the mad rush of students trying to study for their quizzes arrives. So let's see if I can do it. Today we're finishing the chapter with one of the easier sections. We're going to be solving radical equations. So we haven't done a lot of equation solving in a while. I want to get back to that. It's a little bit more straightforward than some of the other things we've been doing. The essential question today is obvious. What techniques can I use to solve? And we're going to be doing equations with square roots and cube roots. Sounds fun. Now, we have to watch out today because there are these things called extraneous solutions. Extraneous solutions are such a big deal in math that it is meme-tastic. Here are just 3 of the memes. This one features prominently on my wall. I'm looking at it right now, if you can imagine me sitting at my desk looking at this meme. So we need to remember, yes, to avoid extraneous solutions. But what are they? We will find out. Here's my favorite meme, condescending Wonka, telling you not to forget to check for extraneous solutions. But again, we're going to see what these things are when we get to solving. So let's get to solving. I have 3 examples for you today. Our first example, we have the cube root of something. Now, we can very easily cancel this cube root by doing what? Well, all I have to do is cube both sides. This cancels the cube root and leaves me with 2x plus 7 equals 27. Now, the reason I was able to do this so easily was because the cube root was isolated. And as I've looked over some of your tests and quizzes, I've noticed that people have tried to cancel these things without isolating them first. Here, the cube root is the only thing on the left-hand side of the equation. It is isolated, so when I take the cube root of both sides, it's legit and it cancels. From here, it's easy. Just subtract 7, 2x equals 20, and then divide by 2 to get that x equals 10. However, we need to make sure that this is not an extraneous solution. Otherwise, condescending Wonka will get very angry at me. So let's just make sure that this answer does work in the equation. Because basically what an extraneous solution is it's an answer that seems like it works, but doesn't work. And we'll talk about why. But let's just double check this. I can plug it back in. So I have the cube root of 2 times 10 plus 7. And I want to check to make sure that's 3. So is 2 times 10, that's 20, plus 7 is 27. So I have the cube root of 27. And of course, the cube root of 27 is 3. Check. I know that this is indeed an example of an answer. It's not an extraneous solution. This is a legit answer. All right, so next problem, 2 of 3. Now remember what I said last time, you really need to make sure to isolate the cube root. So here, I need to isolate this thing before canceling it. So let's start by adding 1 to both sides. That'll give me 2 times x plus 2 to the 3 over 4 equals 16. So I added 1 to both sides. Now, here's where I saw a lot of people going wrong. You got excited. You thought, oh boy, now it's time to cancel the exponent. And you know that if I take both sides to the 4/3, that's going to cancel the exponent because these exponents multiply. Yay, they cancel. But don't forget that if you take this side to the 4/3, you also need to do the coefficient to the 4/3 as well. And I don't know what the 4/3 power of 2 is. So we cannot simply start by taking the 4/3. As Boromir would say, one does not simply take the inverse of an exponent without first isolating. Let's isolate, and we're going to isolate by dividing through by 2. So now I have x plus 2 to the 3/4 equals 8. Now, have I isolated? Yes, definitely. This is the only exponent on this side. There's nothing else like a coefficient or an added or subtracted term at the end. So I'm good. We're going to raise both sides to the 4/3 because we know that the rule is exponents multiply, and since these are reciprocals, they cancel. So I have x plus 2 because the 3/4 canceled, but of course I need to do the same thing to the other side. So what's 8 to the 4/3? Well, remember, 8 to the 4/3 is the cube root of 8, 2, and then to the fourth. So 16. So x plus 2 equals 16. It's not 8 times 4 over 3. It's 8 cube rooted and then to the fourth. So at this point, it's easy. I just need to subtract 2. X should be 14. But remember, this could be an extraneous solution. This could be a situation where it looks like a solution, but it's not actually one. So let's plug back in. And when I plug back in, I can make sure to follow good order of operations. Order of operations, PEMDAS, says do parentheses first. This is 16. So 16 to the 3/4 minus 1. I'm trying to see if that's equal to 15. Next, parentheses, done. Next is exponent. So what's 16 to the 3/4? Remember, that means the fourth root of 16, which is 2, and then 2 cubed, which is 8. And from here, you should be able to easily tell 2 times 8 is 16. 16 minus 1 is 15. So I have 15 equals 15. This is a real answer. It is not an extraneous solution. So it seems like I've been talking about these extraneous solutions a lot. Maybe they'll show up eventually. And as it turns out, I think this problem is going to have an extraneous solution. We have a couple things to worry about here. First of all, we need to worry about canceling this square root. But it's going to be a little more tricky because there is an x on the other side as well. However, I would rather have x's on both sides and ugliness with squaring things than I would have a square. So I need to cancel the square. Here, the square is definitely isolated. Look, even though I have this weirdness on the other side, on the right-hand side, I only have a square root. So that means if I square both sides, it will cancel the square root. So, x squared plus 1, right? Wrong. This is not at all how it works. Remember that when you do something, you must do it to the entire side. So I need to square the entire side. I need to square all of x plus 1. And if you remember from previous chapters, you must FOIL this. You are not allowed to distribute in. You must FOIL. There will be many people that aren't paying attention to this video right now that forget to FOIL. Don't be that guy. Be the guy that pays attention. Use your intellect to the best of your ability. Remember that this is actually x plus 1 times x plus 1. That's what it means to square a binomial. So let's do the FOIL. I have x squared. I have 1x and then another 1x, so that's 2x, and then I have plus 1. If you need a refresher on FOIL, like go back, I don't know, ask your younger sibling who's in Algebra 1 or pre-algebra. So at this point, I have gotten rid of the square root. Even though it made me do some ugly FOILing on the left-hand side, at least I don't have a square root on the right-hand side. But I have another issue, a squared term. How do I deal with this? Well, as it turns out, this is a quadratic. We know a couple different methods of solving quadratics, but they basically all start with getting a 0 on this right-hand side. So let's start by subtracting 7x. And I'm combining like terms here, so let's also subtract 15. This gives me x squared equals silly Mr. Gregory, x squared minus 5x minus 14. Now at this point, I have a couple different ways of solving. I could factor, so I should see if I can factor and then use the zero product property. If I can't do that, I could also use the quadratic formula, you know, that x equals negative b plus or minus the square root. But I don't want to do that if I don't have to. Let's see if I can factor. And as it turns out, this does factor into x minus 7 times x plus 2. If you need a refresher on how to factor, this is not the video for it. I'm not going to waste your time. Go back, watch like 4 point, I don't know, something to see how to factor. The point is, now I'm using the zero product property. From this factor, x would equal 7. From this factor, x would equal negative 2. So it looks like I have two answers, but we need to check. So let's plug 7 back into the equation. On the left-hand side, I have 7 plus 1. On the right-hand side, I have 7 times 7 plus 15. So 7 plus 1, 8. On the right-hand side, 7 times 7 is 49. 49 plus 15 is 64. And yeah, the square root of 64 is indeed 8. So it looks like 7 is an answer that definitely works. Let's see what happens if I plug in negative 2. So negative 2 plus 1 equals square root of 7 times negative 2 plus 15. Now on the right-hand side, negative 2 plus 1 is negative 1. And already I see an issue. But let's keep going. 7 times negative 2 is negative 14. Negative 14 plus 15 is 1. What's the deal here? Can I get a square root as a negative? No, it's not possible. The square root of 1 is positive 1 because when I take square roots, it's always a positive number. So is this true? No, this is actually not equal. And the reason is, look, it's kind of a plus or minus thing. Remember how when I'm doing square roots, there's sort of pluses and minuses involved? Well, here, the equation, the way I solved it, thinks that when I take this square root, I should get a negative number. But we know that's actually not how square roots work. So this x equals negative 2, as it turns out, is an extraneous solution. It's a solution that looks like it's going to work, but actually when we check it, we find out there's an issue with the plus minus stuff. So every time you have a square root in your problem, or any even root, because we know there's plus and minus stuff going on, I need to be checking to make sure that that doesn't come out when I actually check the answer. Since x equals negative 2 is an extraneous root, we cannot count it as an answer. It doesn't actually work in the problem. It looks like it's going to, but then the plus minus stuff actually causes it not to. So our only answer is x equals negative 7. Wow, what a satisfying and rewarding video. I don't even have a summary for you today, just a blank slide. My one summary would be this. Make sure to isolate. You need to isolate before you cube. Here, isolate before you do to the 4/3. Here, isolate before you square. It's very important to isolate. And don't forget to check for these extraneous solutions. All right, see ya.